Right, in this video, what we're going to do is we're going to talk about testing the difference in two means, particularly about independent samples. By independent samples, we mean that the samples for our two means don't have anything to do with each other. Right, and the story that we're going to go around here is that Chifaru loves baseball, and she's wondering about the difference in batting between the American League and the National League. She does some calculations, calculates the mean National League OPS, that's on base plus slugging, is .443 with a standard deviation of .63, right? This is a sample standard deviation and a sample mean for 122 selected players in the National League. For the American League, she calculates a OPS of .433 with a standard deviation of .061 for 136 players, right? So we don't need our sample sizes to be the same, but they need to be large enough again, right? They need to be large enough to satisfy our central limit theorem. And what she wants to know is, right, is this a statistically significant difference in the leagues, right? .443 and .433 are different, but is it different enough to matter, right? And if so, how big a difference can be expected, right? And this part we'll do in a shorter video coming up. To check and see whether or not our population means are reasonably expected to be the same, we're going to do a hypothesis test, right? So let's rush through a little memory of our hypothesis test. We're going to have a null and alternative hypotheses. And it's either going to be a left, right, or two-tailed test. We're going to have some significance level alpha that will determine where our reject and fail regions are. We're going to calculate a p-value for our null hypothesis and type of test using our sample data. And depending upon the relationship between our p-value and our alpha, we're going to reject our null hypothesis if our p-value is smaller than alpha, and we're going to fail to reject if our p-value is larger. And then we're going to state a conclusion based on our findings. So first, let's talk about our null and alternative hypotheses. When we're comparing our two means, right, our mu1 for one population or mu2 for another population, in comparing them, our null hypothesis is that they're always going to be equal to each other. So it's going to look like our null hypothesis is that mu1, or mean for the first population, is going to be equal to the mean for our second population. Our alternative hypotheses, again, will come in three types. Either the mean from the first population, we're going to test it that it's less than our second population. Right, this is our classic left-tailed test, arrow points to the left. The mean for our first population is larger than the mean for our second population. That's going to be our right-tailed test. And then lastly, if we're just looking at whether or not they're equal or not equal, this is our classic two-tailed test. All right, now we have to label things properly. Right, in Chifaru's example, we're going to let the American League be our ones. So the mean for our sample 1 is going to be .433. Our sample standard deviation for our population 1 is going to be .61. And our sample size for the American League, our ones, is going to be 136. So if our American League is our ones, then our National League has got to be the twos. So again, labeling things properly. Our sample mean for population 2 is .443. Our standard deviation for our second sample is .63. And the sample size for our National League, our twos, is 122. Right, so consistent with our labeling, our mu1 is going to be our mean for the American League. Our mu2 is going to be the mean for the National League. Ones go with ones, twos go with twos. For a null hypothesis, we are assuming that mu1 and mu2 are the same. And so mu1 is equal to mu2 as our null hypothesis. So for our alternative hypothesis, it looks kind of right away like our x2 is higher, right? 0.443 is higher than 0.433. So let's do that test. Let's assume that the populations follow these samples, right? mu2 is larger than mu1. Our arrow is pointing left, so this is going to be a left-tailed test. All right, so let's choose a level of significance. This really isn't that important, so let's kind of keep a high level of significance. All right, let's look at a significance level of 0.1. Next, we're going to look at how to get our TI calculators to give us the p-values that we always want to make this decision about whether or not to fail to reject our null hypothesis or to reject the null hypothesis and accept the alternative hypothesis. All right, so opening up your TI-84 calculator or equivalent, we want to look under Stats, we look under Tests. All right, so hit the Stat button, go to Tests, and the thing we're looking for in this case is a two-sample t-test. It's a t-test because we're using sample means and sample standard deviations. And going through our inputs, since we have our statistics rather than the raw data, we want to choose as our input stats rather than data. Then we want to input our numbers. First for our ones, our American League, then for our twos, our National League. The mean for 1, our American League, is 0.433, our standard deviation is 0.061, and we had 136 ball players in this set for the American League. In the National League, we had a mean of 0.443, a sample standard deviation of 0.063, and we only had 122 ball players in that. We're assuming we're testing against mu1 is less than mu2. We are not pooling our data. I'll talk briefly about this in class. And then we hit calculate. And next I'm going to talk you through our output. So the top of our output simply says that we've done a two-sample t-test and that we've tested them being the same against mu1 being less than mu2. So the American League would be less than the National League. The first number under this is going to be t is, I got about negative 1.292 and a bunch of other digits. This is our test statistic. This has to do with our students' t-distribution. Right? It tells me that the value that we got is going to be right here, and the p-value is going to be this area that we got under here. Right, for a student's t-distribution for a certain number of degrees of freedom. Right, that p-value, that area under the curve, this is the thing that we want. Right, this is 0.0987, right? That's our classic p-value. That's the thing we compare against alpha, and our alpha was 0.10. P-value is less than alpha. That'll reject our null hypothesis. The thing directly under the p-value is our degrees of freedom. Right, remember, the degrees of freedom is incredibly important in the student's t-distribution because it changes the shape. The degrees of freedom calculation that the calculator uses reasonably complicated. It's certainly not something I would expect you to do by hand. I'll briefly mention it in class. It's toward the end of this section in the book. But the idea is that we had 136 data points for one sample, 122 for the other, and this degrees of freedom of 250.9915 yada yada is some combination of these that has to do with not only how many data points, but as the standard deviations as well. Right? All of the other outputs, the x1 bar, x2 bar, sx1, sx2, those are things that we had already inputted, so I'm not going to mention them. But for us, in terms of our hypothesis test, right, our hypothesis test, remember, was that our mu1 is equal to mu2, right? So the American League OPS is equal to the National League OPS. Our alternative hypotheses is that the American League OPS was less than the National League OPS. And we chose a significance level of 0.1. 0.1 was greater than our p, so our p is less than alpha. So we will reject the null hypothesis, right? That's not going to be true. We will accept our alternative hypothesis. And the conclusion we draw is based on this, that the American League has an OPS lower than our National League. And it's going to look something like this. The data is sufficient to show that the National League had a higher OPS than the American League. So we have an upcoming video next about how to kind of calculate what this difference is. And otherwise, we'll see you in class.